Good morning, everyone, and welcome to the week 6 of the Artificial Intelligence Research and Creative Activities Clinic. So during the week 5, we learned how to clean and verify data. We studied how to identify missing values, correct inconsistencies, standardize categories, and make sure that the data set is ready for analysis. Today, we will move from clean data to research level analysis. We will start with the research question, examine the data, calculate statistics, study relationship, build an exploratory model, generate figures, and verify the results. Yeah, I know that this week it's a little bit heavy, but we need it to, I'd say, to speed up the process and to give more courses and util courses to the community. So this is why I put all together, just because we cannot divide. If we divide, so it will we will not, I would say, week 7. When we will come back, we will not, I would say, it will not be coordinated. So it's much better to have all of them in 1 week, in one session. And if we have questions or we have more questions, we can always, I would say, deal with these questions during the office hours. So we will use AI for sure to help us to write and organize the code, but the researcher remains responsible. As always, I am saying, responsible for every number, figure, and conclusion. The data set used today is completely synthetic. So I generate this data set, and I will show how to generate a data set. This means that the generated for teaching purpose and contains no real students information. So let us begin with understanding what we should say, how to say, by understanding the difference between cleaning data and producing actual research results. So from in week 5, as we said, our objective was to make the data trustworthy. We checked whether the columns were correct, whether the values are missing, whether the categories were consistent, and whether impossible values are exist. So, however, clean data doesn't mean how to say we are in research level. A clean spreadsheet doesn't mean the answer of the question. To produce a research evidence, we must define how to say what we want to investigate, select the appropriate statistical method, interpret results carefully. So it's not we have clean data means that, or we have good figure means that we have good research. We are in research level, so we need to know which question we should ask and what are the limitations, what are the results that we have. The results are accurate, not accurate. This is very important point. So professionally designed graph can still present a weak and or incorrect analysis. Therefore, every result we present should clearly show the sample size, the missing values, the variability, and the uncertainty. So how I'd say the main points, or the 9 points that we need to deal in each research is first the question, audit the data, describe it, compare, relate, model the data. So which model we should use it, which how to say the relationship between the model and the data. So then we should visualize this data, and the visualization is not, I would say, boom, we have a good figure. No, it's not like that. It's the figure is can author interpret what we want to say in the paper. So, and then we should verify by ourselves, is this visualization are consistent or not? Then we move to the report. This is very important. So before how to say, always before questioning code, between writing the code, we need to ask the right question, and we need to write it first. This question is the most important point in any research. So what we want to do, the motivation that we are how to say, what exactly wants to do with our research, what's the results that we are expected to have, and what's problem that we are dealing. So the questions that we are asking for the code, to write the code, it's not, for example, we can say analyze this data. It's very, very weak question to the AI. AI can interpret this, analyze this data set, and it can provide us any answer he wants to provide. So we need to be very, very descriptive. So how are our study hours, sleep, stress, attendance, assessments, stories, scores. So this what we want to do, and how we want to compare this data. This is also very very important. So before entering to the research level, we need always to have the ask also about the relationship between the data set and the models, and how to say, what we want to have as a result. So we have the first thing, we have the data set. Second, we have the model that we want to use, and third, we have the results and the relationship, or the relationship between them, and how I'd say this result justify our thinking, how to say, our thinking, or what we want to do with this data set. So we can say, for example, what we can say, and what we cannot automatically say. So the variables are associated with the data set. One group has different observed mean. An estimated relationship has a quantified uncertainty. The model describes patterns in the variable sample. On the other side, one variable caused another. AI used improved performance, finding general to all the students, and the model is suitable for individual decision. What does it mean? This means that if we keep how to say, the opportunity, the AI, it will so let's say, for example, let's say clean this data, or give me the autocorrelation, or the correlation between column 1 and column 2. This is, we are precising to give us the correlation between column 2 and column. But imagine that we say, provide me the correlation. The correlation, it will imagine how many columns, and he will provide you all columns that maybe you don't need to have this correlation. So this is only just an example, but we can generalize it. We need to be very, very precise, and what we want from the AI tool to generate us and to provide us, because also we need to be cautious about the results itself. It can, for example, we can say with good heart, we can say, I want to write a code that provide me very, very good results. Means you mean in your heart, you mean in your mind that with good visualization, but you say a good results. For 100%, the AI tool, it will generate a code that it will give you very good results, but fake results, not correct. So, and you are asking the wrong question. So the correct question that we need to ask is, we need to be precise. We need first what we want to do, what we want the AI to do for us. It's not giving the opportunity to the AI, and it can diverge for other questions or other calls. This is very important. So the data set that we want to create, today is how to say, we ask the AI tool to provide us a data set that it's reproducible first, no real records, no of persons, unusual how to say plausible cases, missing values less than 3%. We have 8 variables and 500 observations. So we have 500 by 8 matrix if we want to do that. Also, we have real data, but provided by University of California Irvine. So they gave the number of the how to say the real data in with the permissions for sure, but they are very powerful to provide a lot of it. It's not only this data. If you want to use other data for your research, you'll find a lot of data in UCI website that I provide here, only performance, but you can use archive.ics.uci.education dataset. You'll find a lot of data sets that are real data set, and you can use it either for weather, for atmosphere, for environment, for how to say solar energy. You can find a lot of data set that, and it's the most important thing is that it's licensed, free of use. And but we need only to cite them, and you can modify the data set. So this is the license that they provide, and you can also use it. We didn't use it in this, but just if you want to validate what we are doing today using 8 by 500, the code, same code, you can ask the AI to modify it and to download this data set and update, I would say, validate the code that we are using to the real data sets, and it will give more power to your code. So here we are not using real data, and in all cases, even though you have this data, download it. Just always we need to use synthetic data to test ourselves first, to test our in local, to test our algorithms are working, not working, based on our knowledge. Then we should move to the realistic data set that it will help to validate the system and also to help the paper. To if you use the data set in real data set, real experiments is much better than simulated or synthetic data set. So the purpose for how to say what we want to do today, we based on the 9 points, we have nine functions that we need to generate or to use to in this course. So the first we need to load the data and compute this descriptive statistics, analyze relationships, create I am going to the how to say vertical. I need to go horizontal. So first we need to load the data and audit the data set. So we need to verify this data set is clean or not. Then compute the descriptive statistics, the mean, the count, the spread, plus missing. We can compute the covariance, the variance, the how to say the percentage quantiles for the first, the second, or the fourth quantiles, percentage quantiles that give us an idea, statistical interpretation of the data set. Then compute the global of the group of the statistics, for example, the whole department's mean, or the confidence interval to 97.5, the numbers, and so on. Then we analyze the relationship between all the pairs. So between, for example, we have the Department of Art and the Department of Mathematics. We compute the mean of this for example, I'm just saying an example. The mathematics, we compute the average of the students there and the average of the students in the Department of Art. but they are independent here. So if we want to have a relationship between what's the relationship between them, we need to compute the correlation coefficients, what we call Pearson correlation, and compute the complete pairs. So what is the relationship not only between the number of students, or we can compute the marks, the how to say the rate of success. We can have any kind of comparison that we want to compare. So it is how to say, it is always good to have the relationship. Then, based on this correlationship, we can have the I would say if the systems are linear, we can have I would say the correlation. For example, it will be x equals beta multiplied by y, or the inverse. There is no matter to use y or x or z. The idea is, what is the value of beta? Beta is the coefficient of the correlation that we have it from the 0.5. So, and the fit and the regression is based on the system. If the system is, for example, linear, we can use the linear how to say regression models. If the system is non-linear, we need to use other non-linear systems coming from the non-autoregressive models to the shallow neural networks, and then deep learning neural networks, and so on, and transformers, and so on. It's also based on the data set. So no need to use if you have 500. It's if you ask I would say someone that is not very professional in AI. I am not very professional not in AI. I will not accept to use transformers for 500 data set, because you will have overfitting, and it will not provide you good I would say inference later on. So, but if you have 5 million data sets, much better to use transformers in this case, and much better to use a very big deep learning model to have the regression. But in this case also you need high computational resources, big GPUs, and how to say with multi-processors, multi-CPUs. So this is very important point that we need to understand. This is how we say which model we should use. Why I'm saying like that is just an example, but which model we should use is based on your application. It's based on the application itself. It's not I can use transformer because it's the buzzword. For example, I can use LLM because they are using LLM or VLM or GPT. No, it's not like that. It's based on the data set. It's based on what we want to do. We can use the model, the appropriate model for it. And honestly, it's also we need to make always a literature review before doing anything, because also to don't do something that it was already done, and it's also very important to find. Then we should create the figures. The publication ready figures is not the same figures. So you can create the figure, but with a small font, or without legends, or these are not publication ready. The publication ready means that they are legible in normal A4 double column, let's say for IEEE transactions. So also it's very important to provide the good figures that shows that legible, that we can read without zooming in the figure. This is very important to avoid, I would say, the extra questions. And then after having the results, we need to verify these results are good or not. These results are consistent or not. Maybe the figure is good, the coefficient or the correlation is good, but the data set that we are using, we are correlating. Just I'm saying correlating the number of students and the marks, and we are already have the marks from the marks to the mean, and we have the number of students from the marks to the mean. So we will have a very correlated graph, and beta will be the correlation coefficient will be around 1. But if we have worse data, so the coefficient of correlation, it will be down and it will go to 0. In this case, the data set, they are not correlated. So they are not, we can say the data set are not, I would say there is no relation, are independent data sets, or there is no relationship between these data sets. If the case is true, that's good. But if the case is not true, and you know before that, by your knowledge, that they are correlated, so these results are wrong, and you need to revise to go back to your even to 2.1. Maybe you upload data that or you load the data they are not or the wrong data set that normally you should not use. This is very important. So more code does not have, this is the main idea that we need to notice here. More code does not have to mean less control when each function has one clear purpose. So write full code is not good to have it, I would say, or doesn't mean that we don't have less control. We can have control on the whole code, and we can have the control of each function, but you can when you can come back from 8 to 1, you can know that 1 is correct, and how to say, verify only 1, then go to 2, verify it, and pass to 3. To don't go immediately from 1 to 9, then you will restart, and you don't know exactly which function that you are working on, or it provide the mistake. Let's say it's not error, but the mistake, because bug, let's say, it's not a statistical error, it's a logical error. This is more important than the syntax. The editor or the AI that can help us to find it. So this is just an example here. Just I tell the Copilot to write me a synthetic data set using this code, and it took, I don't know how many times here, but it took more than 2 minutes. This I start from scratch. Just I will come back to here. So start from scratch. So here I when you open the how to say, the Visual Studio Code, it will how to say, ask you provide me the working folder. So this is what I am doing here. I will provide him the working folder. This working folder is I created for how to say, for this week only. Then I provide the code to write, because it takes a lot of time to write, but this code you will find it later on in AIRCAC, just to tell him before continue, I want to explain one thing here. SEED 2026 means that everybody use the same code, he will find the same data set that I find. So this seeding means that I am providing a code reproducible. If I remove seed here, remove this seed, because when we have random numbers, always if we don't use seed here, it will provide us random data set based on in your computer, in your timing of using, and so on. But when we use seed here, and you use the same seed in your site, 100% we will have and use the same code, because seed here only works for NumPy. It will not work for Torch. It will not work for other packages. Only we are using NumPy here, or regular Python functions. We have seed here to 2026. You can use any number, so there is no problem here. But the same number that you are using, I need to use it, and the reproducibility of the how to say, this data set, generated data set, by using the same code, we will have the same data set generated if we use the same seed here. So here we are running this generate synthetic data set. We will have it here in data. So what we ask the code here to generate 500 by 8. We give 8 here, 8 departments. The departments we have 8 here. If you don't, I would say just per curiosity, if you want to understand any function here, only we need simply to ask this. For example, explain line 9 or explain the function of the line 11. It will explain you the full function, and then we will have the generated data set. It's in data set here. It's synthetic data set. So this is generated, and when you use, I repeat, when you use the same seed here, you will find the same synthetic data set generated on my site. And in all computers that you use the same code with the same seed, you will have the same data set. Then we generate the data set here. We generate the data set. Now we need to inspect and analyze as we did before in the week 5. And I will go quickly here. Just as we did in the week 5, the audit. We need to have the values or the statistics or the values are missing, not missing, clean, not clean, and have the percentage of the students, what we the missed values, what we have as is this data set, I would say, that we generated respect the what we say, the requirement that we provide before that, less than 30% missing data sets and so on. If it's okay, so we can have I would say we can move to the next step. If no, we need to revise either the code of generation, either the audit code data set, by the same mean here when we ask the AI to help. So you can use this prompt here to write you the code, but look here, we insist, and we tell him, do not modify the data set. Save the audit tables in the results audits and print the concise summary. This we told him. If we don't tell him, if we stop only here, it may. It's not 100%, but it may touch the data set. It may don't save the audit tables. It also doesn't print the data set as we told him. So what I want to say, we need always to don't keep a small window open for the AI to go. Always we need to give him all the things that we want, and to let him focus on what we want to do exactly. This is very important. So then what we find after how to say this, I copy paste from here. When we run the code, I copy the values from these results. I copy them here just to understand what we have. So we have true. We have 500 rows by 8 columns. We have 90 missing cells totals. So it's 3% per variable. No duplicate rows. We have the computer science 119, we have the education 109, the engineering 108, business 87, and art 77. Also we have the variable ranges and the potential outliner here. It's we use the IQR, which how to say, provide us the statistical measure between quantile, third quantile, and the fourth quantile percentage. It means that we have from 0 to 25, and we have from the 25 to 50, and we have 50 to 75, and we have the fourth is 75 to 75 to 100, so it's 25%. And this IQR, what we call it the interquantile range, is as I said, the Q3 minus Q1. How to say, it gives us statistical value between the number of how to say the third category and the first category. Then we how to say, we want now to move to the third point and describe the data set. And here we provide this this, how to say, what you call it, prompt to the same AI to generate the Python code. It generates the descriptive statistics. We have the results here. We have three tables, and also when we I didn't explain this, when we ask before the audit, we have also the audit in the results here. And also the tables that we ask to here, we ask to provide the results in the tables. It will provide the results in the tables. And how to say, we can have them as we have 485 valid observations. The mean is 70.56. The range is between 36.5 to 100%. The department means were similar, and the hand check verification was passed by myself. So I didn't just here, just to one information here, I didn't how to say, favorize myself. The AI favorize computer science when it generates the, how to say, the code by itself. But we can modify if we want to specify. So let's say, for example, the Department of Art has more students, so we can specify that the Department of Art has more students, and the AI will modify by itself. So now we need to move to the other how to say point, which is the visualization and the correlation, and how we will have the measures. I will try maybe to if it doesn't take time. It doesn't take, it's 1 minute. So running. So it takes the same data set that it was verified before by the AI and by ourselves, and it will provide us the figures that we will have. This is the correlation. The correlation. I will stop a little bit here. This is the correlation between, what is this? The correlation between the six departments and which each other. But here, so let's say for the yellow, the department with itself, it is the highest, and it's true. So, but we can see here the green, when it goes to the blue here, it's not correlates. It means that I don't see very well this one. But this let's say this 1, 2, 3, 4, 5. The 5 point is not correlated with the second point here. and it is the stress hour. The stress hour from the department, one department is not how to say correlated with the other one. So here we need to analyze this data set by ourselves and see how it goes, and what means the look here. We have find R equals 1, means that we have and it's true, we have 100 correlation between study hour and studies hour in the, but between sleep hours and study hours we have 0.08, so it's very low. Here we have the R, it's sorry, it's we have 0.8. So the 471, and here we have 484. Almost all the sleep hours are I would say correlated with the study hours. So there is an equilibrium. But let's say, for example, this point, I don't know what is this point here. This point is not correlated with the sleep hours. I don't know how to go back here, but the code it can be run, and you can find how to say, you can study by yourself these values that we have. So what's I have only a research note here that the person measure linear association is not prove causation, and may mislead when assumption, outlines, and non-linear relationship are ignored. So what does it mean this? If the relationship is really or non-linear, and we are using the person node, means that we are using the wrong how to say, the wrong interpretation, if we can say like that. So if the relationship is non-linear, the person correlation coefficient is not the right choice. We need to have other ways to study the relationship between the models. Now let's, how to say, let's don't give her this example. Give us don't how to say provide the AI tool to predict what he wants to, how to say, to predict for us. So we want it to give us the right parameters and the right things. He needs to use the right predictors. So don't let him predict or use its predictors. So I provide this I would say this prompt to the AI tool, and we will it will generate how to say, and we told him just this is also an example, just OLS it's how to say, it's ordinary least squares. So just it's another measure that we can use it to compute the errors, or to have an idea about the errors between the plots. And also we provide him the predictors that he needs to use: the study hours, the attendance rate, the sleep hours, the stress hours, and the AI use hours. So here we give this data set. This data set contains also how many the students, how they are using, how much time they are using the AI tool in their studies, and we need to know, to have an assessment scores for that, not only for that, but in between the study hours and how many AI tools they are using, how much the stress scores, and so on. And we provide him 1 to 9 points that he needs to follow to generate the code. This is, to be honest, this is not an exploratory teaching model, because we don't have, it's not an evidence for intervention or policy or policy grading or individual decision. So it's only a model that I use it. But we need to have, if you want to use AI, you need to have your own model to how to say to use. So here it generates the how to say the, let me pass it like that just it provides here the data set in figures, and it provides the how to say the ordinary least square distances. It's very important parameter, residual q plot, which provide us, this is very important also to, this is just here I will come. This is very important because based on, we can have the correlation between here. What does this mean? The simple quantiles and quantities and the quantiles and the theoretical quantities. So is our model follow the theory or not? This is provide us the information. If it is how to say near to this red line, means that they are correlated. They are how to say they are dependent to each other, and they are very good. If we have, I will show you another one. If we have something like that, they are not correlated at all. So there is no relationship between the rational and the fitted assessment scores. So there is no relationship between residuals and fitted values, and so on. For the other one also, we have here the scale location plot, the fitted assessment scores, and the square roots, how to say, they are also independent. This provides us the information that our scores are not correlated. It's not the data set is not correlated. And this is just an example, but we can find how to say other we can always use other techniques. This is for someone who uses statistics, but for another one that he wants to go more, he can use other AI tool, other models, more advanced models for his research. So for the model specification, the outcome is assessment score, and we will have the how to say the OLS with intercepts. The simple information, we have already 500 total observations, and we have 418 used modeling. 82 was removed due to the missing model variables. All estimates based on the only for valid 418 complete cases. So the main results, the positive adjustment association is positive because we have the how to say the score, p-score is less than 0.001, and we have the attendance rate is also positive because we have the p-score is less than 0.001. The sleep hours, the stress hours, and the AI use hours were not statistically significant. Means that they are not I would say it's not significant. Someone is using, but not regularly. Someone is used regularly, and we cannot compare their use. The model assessment, the residuals, the diagnosis shows that no major systematic patterns. We have two large standardized residuals identified. We have 22 potential influential observations from the Cook's distance, and no casual interpretation. The validity depends on the model assumption and diagnostic how to say review. So all this information are provided by the AI, and for my side I verified. When you use other data set, when you use other models, you need to do the same thing and you need to verify, double check, and based on your specialty, because my specialty is not, I am not chemical engineering. I don't know. So even though you provide me the results, I cannot interpret. For example, just I'm saying I am not expert, but just I'm saying I'm expert in mathematics. I can interpret. If you provide me some results, I can say this wrong. AI is not you provide me. If the AI provides some results, I can interpret and they can say this is right and this is wrong, and I can have my decision. And based on these values, then I can decide also that these values are correct or not based on my observation. So we need here to always need how to say simple checks in complex pipeline. Always we need to start with manual calculation, independent recomputes, small tables and figures that we need to have to confirm that our summary and the raw accounting. And these examples provide us, it's very simple. It's true that they are very simple, but this provide us how we can deal with big example. So if you want, for example, to have the speed from the IMU, and it's just an example. You need to have you need to know the IMU. What are the functions provided by the IMU? Then after that, you can decide what they can have from the IMU. You cannot have the position from the IMU long time, because the IMU doesn't provide the position. It provides the acceleration, and if you want to have the acceleration, you need to double integrate the undefined integral. You have double integral, undefined integral of the acceleration to have the position. So you have double unknown c's coming to the equation, and therefore you cannot estimate the position for long term using only the IMU. And then you need to have other examples. But why I'm saying like that, this is just a simple example that if we want to have big thing, we need always to start for small things and always merge them together, and one complement the others. Because if you start with complex, I don't know, you hear about the hyper complex numbers, that we have the complex numbers real plus I imaginary part, but we can have the quantarium, we can have octonion, we can have the sedanium, that they have one number and one real number and 15 imaginary numbers not related to each other. So the I and J, K, and so on are not related. And if you start now, you want to know sedanium numbers without knowing the real number and the complex number, you are doing the, I would say, you are going to the forbidden way, and you will not, I would say, have the you will not have understand exactly what does mean sedanium. This is just a general example that I provide. Always we need to start from not from the bottom, from the top to the bottom. We need to start from the bottom and go into the top, assuming that the top is the complex part. So same numbers and honest words. So more AI use caused high performance. The department A performs better, This model predicts student success. The results proves an intervention. But what we can say using our data set, defensive data set, is not that. The inverse. We need to say these synthetic samples. This is synthetic samples. AI use ours had a small observed association with assessment scores. The observed departments means differed, but group size are uncertain uncertainty must be considered. The exploratory model describes adjusted associations in a variable synthetic dataset. No causal conclusion is supported by analysis. So the week 6, this week 6, you will have this I would say this the folder that we will provide. It contains all this I would say codes and spreadsheet. It was empty. It was initially empty, but all of this, it was generated and verified by dataset. It will be as a reference for you to have, how to say, to test the codes by yourself first. Then you can how to say provide the use other your own data set or your own thinking as you want. So the exact the means that if you use the same this, you will have the same the exact input with every column defended, your relative paths, pixels, seeds, one main each for all scripts, and the results audit tables, figures, PNG and PDF, I would say, and the model summary. And also you will have the README plus log, how to run it, and the full run. I put already that in this GitHub, and you can fork it. You can fork the GitHub always in your GitHub, your own GitHub. I gave this permission to fork and to use the model, I would say the codes. So practice task that we need to always to have it: one question, one table, one figure, one check. So don't generate, right? I'd say don't how to say provide the AI 2 or 3 big questions and you want it to generate all the questions. Just choose one first question that this is most important, then run it, audit on your data set, produce the descriptive table, one table that it will describe what's this data set and how you are using. Produce one group of relationship figures, one figure, and verify one value manually. So take only a random value from the table and check it by yourself manually. You need to find the same values provided by the AI. If not, so means that there is something wrong. If you find it as a random, if you want to double check, use another value. That's it. So, and you will, I would say, in that time you can say write defensible finding and one limitation that you can. This limitation is always also a good habit to have it in your papers, in your speeches, in your courses. That nothing is perfect in life. Everything in life, every single thing has limitation, and therefore research is continue to improving. So if we say one paper, in my paper I say that the first and it is the best ever, and I would say I find it's 100% correct, means that I will stop the research after me, and this is not correct. We need always to say limitation for in our papers, not only for to provide that our model has limitation. It's not the case. Also, when we provide limitation and people can use this limitation and cite us and improve our model, and it will be good. So this is, we are providing the limitation of our model that people can use this limitation to help in how to say in improving the research science. So I provide you some links here, the that we need to, you can use it, but in all cases we have the AI. So what we can now defend that we defined a research question before running a code. We audited the data. We reported this the sample size, I would say, and uncertainties. We examined the distribution and the relationship between the variables. We generated the reproducible publication figures. We verified the one results independently. We separate the association from the causation, and we save the complete results package. That is that's this one, week 6 research analysis. Next week we will have more advanced topics and courses. And thank you very much for your listening. And if you have questions, or we should close the, because we have time now. It's almost 1 hour. It didn't compute.
Okay, yeah, in the interest of time, I don't have any questions, but this was fantastic. Thank you for this presentation.
All thanks are for you. Thank you for attending, Professor Kim, and I hope that see you next week. As usual, you are attending the. I learned also from you how to be patient in life.
Oh, wonderful. Well,
Thank
thank you so much. I'll see you next
thank you.
week.
Thank you very much. Bye bye.
Bye.